Okay, in today's class, let us see a little bit more on this differentiation topic. Fine. Now, before going to that, let us summarize what we have studied in the last class. Okay. Now, you have this two animations here. So, if you take a closer look, you will get to understand what we mean by this differentiation actually, right? Now, see in this diagram, they have given limit h tends to 0 is approximately equal to, they have written this as delta y by delta x. Okay, don't take it as delta y by delta x, you take it as dy by dx only. Fine, not a problem, right? Now, one thing what you need to understand from this animation which is on the left is that, see that red line, it is actually a secant, right? Delta y by delta x, it will give you the slope of the secant. Now, as h tends to 0, or you can say delta x, right? Delta x tends to 0, which we call it as dx, right? Now, as delta x tends to 0, as h tends to 0, you are seeing that the slope of the secant approaches the slope of the tangent what we have drawn at that particular point, that orange point. Okay, that orange point, it denotes the function of the value at that particular point C. Okay, see they have given the point C on x-axis and the corresponding value of the function will be given by f of C. Okay, f of C they have given. Fine, right? So this summarizes that. Okay, now for summary you can write like this. If you want, you can write, otherwise you can skip this. Right? So say this is the x-axis and y-axis. Right? Now, so this is x-axis and y-axis. Now we have some function which is f of x, correct? Now I'll ask you what is the instantaneous rate of change of f of x with respect to x, right? Now what we'll do is, we'll write a tangent, correct? So you can say, we'll draw a tangent here. Okay, now see what this tangent, what is the angle made by this tangent with respect to x-axis. So that itself we'll consider it as theta. Okay, that itself we'll consider it as theta, right? Now, as you know y is equal to f of x here, right? So y is equal to f of x, correct? Now we will see, you can say dy by dx. Okay, so that is equal to d divided by dx of f of x, we will say, no problem. Fine, so that is given by the tan theta. Now what is theta? Theta is the angle made by the tangent drawn at that particular point, okay, with respect to the positive x-axis. Fine, so if you remember this, you will not go wrong. All right, now this is about the concept of differentiation, right? Now as I told you, there are many names using which we will actually understand this differentiation, right? Now we'll say differentiation of y with respect to x, correct? Now that is the first, so better to note it down. So dy by dx, this is how we call differentiation of y with respect to x. Now second one, we'll call it as derivative of y with respect to x. Okay, now third one, I think you have noted this down already. Anyways, better to write down again. So we'll also call it as instantaneous rate of change of y with respect to x. Okay, instantaneous rate of change of y with respect to x. Now there are few other names using which we will actually define this differentiation, dy by dx. Okay, now the same thing, dy by dx here, right? We'll also call it as, see, dy divided by dx, that is, what is y here? Differentiation of function of x with respect to x, correct? Differentiation of function of x with respect to x, just like we say differentiation of y with respect to x. Now we have one more notation for this. We'll also call it as f dash of x. Okay, now some people will say f dash, so this small I think you know about this, right? We'll say it as f dash of x. We'll say that small line, whatever we write in the power of f, it is not 1. It is not 1 actually. You just have to say f dash of x. You can also pronounce it as f prime. Okay, while pronouncing it, you can call it as f prime. Few people will say f dash, few people will say f prime. Okay, both mean the same thing, right? Now dy by dx, we'll also define it by using this, right? Now f dash of x or f prime of x, that also means that differentiation of x, right? Okay, right. Differentiation of the function with respect to x. Okay, differentiation of the function with respect to x. Right. Now, yeah, derivative is done, and one more way how we define this dy by dx is that we'll also call it as the differential operator. Okay, differential operator. Fine. Now, you know mathematical operators like plus, minus, then multiplication, division, many are there, modulus, all those things, right? Now differential operator will define it as d divided by dx. Okay, now it feels like when you multiply this d by dx with y, okay, actually it is not multiplication, you just have to take it that way. As I told you, you should not treat dy separately and d and y separately and d and x separately. So this dx itself means it is a value, it is a small change, it just represents a small change. Dy also represents a small change, right? But when you consider this d by dx alone, okay, so we'll call this as differential operator. You just consider that, you know, right, when you have x and y, when you multiply in algebra, we'll say x into y, will simply write it as xy, right? Just treat it that way, right? Now d by dx of, say, you have some other function, f of x, let us say, yeah, okay, or you can say you have one more function, g of x, right? Now both are functions of x only. Okay, now differential operator, when you use this differential operator on these functions, you are basically doing differentiation, that's all. Okay, so this d by dx, you can also call it as differential operator. So you can say d by dx of f of x, will say d by dx of g of x, will say. Okay, so this will call it as this d by dx, we'll call it as the differential operator. All right, fine. Now we'll also call it as this d by dx, we'll also call it as the differential coefficient. Okay, differential coefficient basically means is you are differentiating with respect to some independent variable. Okay, differential coefficient, it also means derivative, differentiation, same things. Okay, right. So d by dx, this itself will consider it as the differential coefficient. Okay, yes, so far so good. Yeah, coming to this d by dx, as I told you, it is called as differential coefficient. Now this was actually the old way of describing the derivative. Nowadays differential coefficient is what we call it as derivative. Okay, now coefficient, usually it refers to a constant value, but this d by dx of some function, see, d by dx simply it doesn't have any meaning, just like a plus symbol or a minus symbol, right? So it is just an operator, you have to use it on some function so that you will get some result, is it not? So just take it like that, fine. So derivative, as I told you, a good way to describe is we'll say derivative of y with respect to x, right? So that is how you can call dy by dx. You can also say differentiation of y with respect to x. Otherwise you can say y is equal to f of x, and you can say dy by dx is actually f dash of x. Okay, so there are many ways using which we will define this differentiation. Okay, so I hope you understood. Fine. Now if you have doubts, please ask. Okay, now let us move on to the next concept in differentiation. Now better to write it down in your notes. Okay, now next we'll go for theorems of differentiation. Okay, theorems of differentiation. Fine. Okay, now coming to the first one, differentiation of a constant. Okay, differentiation of a constant, you can say, where c is a constant. Okay, differentiation of a constant with respect to x or any independent variable. Here when I say x means x is the independent variable, it is actually 0. Now how to understand this? There are a few things which you can understand. Okay, now there are a few things for which you can evaluate this DC, that is derivatives, easily. Okay, there are a few more things which is quite complicated. I'll share you a link to watch that. Fine, so watch it in your free time, so you will get a good idea on this differentiation, right? Calculus. Okay, now say this is x and this is y, fine. Now let us consider the equation y is equal to 2. Okay, y is equal to 2. So this is 0, 1, 2, then this is 1 and 2, right? Now y is equal to 2, what does it represent? It represents a straight line, is it not? So this itself represents y is equal to 2. Okay, now what is this differentiation of a constant is 0? Means what is differentiation basically? It is change in y, the smallest change in y with respect to the change in x, correct? The rate of change of instantaneous rate of change of y with respect to x is what we say, is it not? Fine. Now what we'll do is we'll consider a small change here. Okay, see, let us consider 2 points, point A and B. Okay, point A and B. Fine. Now let us draw perpendiculars on that. Fine. Now say point A and B are so close that the distance between them, right, or the interval what we discussed in the previous class, that is, let it be dx. Okay, let it be dx. Fine. Now when you go from point A to point B, what is the change in x coordinate? Means you can say let the value here be x and the value here will be x plus dx. Okay, so the change, right? So the smallest change what we are seeing is dx. Okay, now when you see the change dx, okay, now what is the corresponding change in y here? Can you see? If you can, it is better if you compare with this diagram here. See, let us take some function here. For example, I'll take y is equal to x. Okay, now all of you know that y is equal to x is a straight line which will pass through the origin. Okay, so this is actually the function y is equal to x, correct? Now if I say here this is point 1, okay, now this is point 2, now correspondingly this is 1 and 2 on the y axis. Okay, right. Now say this is A and this is B. Okay, this is A and this is B, right? Now what we'll do is we'll consider delta x to be this interval. Now what is delta x? 2 minus 1. Now the corresponding delta y, correct? The corresponding delta y, when x changes from 1 to 2, what is the change in y? Y will also change from 1 to 2, correct? So here we got delta x divided by delta y divided by delta x is equal to 1, correct? Because delta x is 2 minus 1, delta y is also 2 minus 1, so we got it as 1, right? Now what we'll do is we will look at the minimum possible value. Okay, now we will look for dx. Fine. Now we will choose 2 points such that point A is here, okay, and point B is here. Okay, now consider these lines itself as the, so consider when I draw perpendicular, right? So when I draw perpendicular here, so you are getting dx. Okay, see, say this interval is dx. Okay, now you have to assume that point A and B are very close. Okay, otherwise you can take some other point P and Q like that. Okay, so these are points P and Q. These are points P and Q. Now assume points P and Q are very close. Now since it is a straight line, okay, so if you observe, okay, if you observe some change in, okay, which color do I choose? Okay, now if you see some change in x, okay, so that is dx here. Okay, now obviously you are seeing some change in y, right? So you are seeing some change in y, dy, is it not? So here in this case, for a small change in dx, you can see a small change in dy, correct? Because that is how the line is, at least from the geometrically you can find that dy by dx, okay, for this y is equal to x, it is actually 1. It is same as delta y by delta x. Okay, now for straight line y is equal to x, delta y by delta x is same as dy by dx. Now if you have understood it better, if you not understood, we will come to know, okay, why it is equal, okay, in the upcoming classes. All right, fine. Now let us head back to that differentiation of a constant. So when you see the differentiation of the constant, what we can see is that no matter how x changes here, okay, no matter how x changes, you will never see the value of y changing. Okay, now you can say for all x, okay, for all x, y is actually 2. Okay, now strictly speaking, y is not a function of x at all, correct? It is not. Y is equal to 2, it is not dependent on x at all, right? So it is always a constant quantity, right? So for all points, okay, for all points of x, you will always see that y is always 2. Okay, so you don't see any change like what we wrote in this dy. Okay, so here if I can write dy, so can I write dy like this? Can I write dy like this? No, I cannot write. So the change in y for some change in x, you don't see any change in y. There is no change in y means dy is actually 0. Okay, so that is all it just says, fine. So therefore differentiation of constant with respect to x. Okay, you just have to see that how the function changes with respect to change in x, right? Now if the function is a constant, if I have taken a constant, now the name itself will say the value of a constant will not change. So no matter what is the change happening in x, the value of constant does not change. So differentiation dy by dx, it basically tells you the change in y with respect to change in x, is it not? So y is not changing, so therefore if it is not changing, we'll say dy is 0, is it not? That's all, fine. So this is one simple proof for why differentiation of a constant is actually 0 with respect to any variable. Okay, right. Now next let us look into the next rule. Okay, so here if you have two functions, okay, let us say u and v are the two functions, we'll choose now, fine. You say u and v are the two functions of x. Okay, let us say, right? Now, and you can say w also, right? U, v and w, u comma okay, u comma v and w are the functions of x. So we have three functions of x basically. Now what we'll do is we will consider the sum of the functions. It's like this. So you can consider sum, okay, otherwise you can consider difference, okay, or you can consider sum and difference like I have written here, or you can consider all, that is u minus v minus w, like that. Okay, so no matter what it is, now what we are going to do here is, if you have the functions added up or subtracted from one another, okay, if you want to find out the differentiation of the sum of functions or difference of functions, right? So generally we will write u plus or minus, that means it can take plus or minus, okay, u plus or minus v plus or minus w, okay, so that will be individually written as d by dx, or you can say du by dx, okay, so that will be, remember u is a function of x, right? Now du by dx plus d plus or minus we have to write dv divided by dx. If you have plus here, plus comes into picture, okay. Now if you have minus here, minus comes into picture here, right? That is all, right? Plus or minus dw by dx, okay. So let us take an example. Here it is like, if you have two functions of x, you can write examples. So you can say d by dx of, okay, you can say x square is a function of x, and 2x, okay, that can be written as d by dx of x square plus d by dx of 2x, okay, d by dx of 2x, fine, that's all. Okay, so this is, now what are these values, we will learn them in the upcoming topics, fine. Now this is this is one more theorem number 2. Now the next one, this is important. When you have the product of two functions, okay, say u and v are the functions. Now u, v, it is the product of two functions, okay, product of two functions, let us say, okay. Then the differentiation of the product of two functions, we'll write it as u, first we'll consider u, okay, first we'll consider u, okay, then we'll consider v, fine. Now remember this. So d by dx of the product of two functions u, v, we'll write it as u dv divided by dx, okay, plus v du divided by dx, okay. First comes u, then differentiation of the v, plus added with v differentiation of u. Okay, fine. So differentiation of uv. Okay, so this will be given as u dv divided by dx plus v du divided by dx. Okay, right. Fine. Now you need to remember what these values represent. Okay, so dx, dv, du. Okay, all those things. All right, fine. Now, yeah, example. If you take an example, you can say u is equal to some. You can say like x square, and v is equal to x cube plus 1. Okay, or you can say 2x square plus 3. Okay, like that. Okay, then you can say d by dx of x square into, okay, of x square into 2x square plus 3. Okay, so this you could have written this as x square. Okay, you can evaluate this as x square times d divided by dx of v, that is 2x square plus 3. Okay, this is not the final result. What is the final result? We'll see next. Okay, there are a few more things which you need to learn. Fine. Now I have u. See, this is u, then this is v. Okay, so I have u written over here. Okay, so this is u basically, right? Then I'm doing dv, right? So this is v. Now next plus v, right? So v is actually 2x square plus 3. Okay, so this is actually our v. Then du divided by dx. Okay, right? So du, what is u? U is x square. Okay, d by dx of x square, right? Now this x square is actually your u. Okay, so this is how we'll write. Fine. Yeah, this is actually our u. Okay, I hope you understood. Fine. Now there is next one, fourth one. Okay, fourth one. We look at the ratio of two functions. Say u is a function of x and v is a function of x. Now you have the ratio of two functions of x, right? Now in that case, how can you find out d by dx of u by v? Okay, now this is important, remember. So with this we will define it as, you don't have the proofs for this, you just have to remember them. First write v square in the denominator. Okay, see what is the denominator? V, right? Now the result, the differentiation of u by v. Okay, so first write v square in the denominator, then we'll write it as v du divided by dx minus u dv divided by dx. Okay, this is quite the opposite. Here first we'll do u dv by dx, right? See, u dv by dx plus v du by dx. It is quite the opposite. You just have v du by dx, except that you have a plus sign here. You have to you should not write plus sign, you have to write minus sign. Okay, v du by dx minus u dv by dx. Okay, fine. So this is how we evaluate the differentiation of the ratio of two functions of x. Okay, fine. Please write all these things in your notes. Okay, right. Now the next function, the next theorem what we have here is 23. The next theorem is, you can say y is a function of x. Okay, y is a function of x. Now that function of x is actually multiplied by a constant. Okay, for example, y is equal to, say, like 3 times x square. Okay, so 3x square, it is no doubt that it is a function of x, right? Now in this case, okay, so in this case what we'll do is, so when you have this way, so you can take this 3 as a constant. Okay, so you can take this 3 as a constant, then dy by dx. Okay, so we'll actually write it as the constant first. Okay, so dy by dx, so let me write like this. So y is equal to c u, like that. Okay, so c is constant. Now u is a function of x. Okay, u is a function of x, let us say. Okay, then dy by dx, you can actually write it as, we will calculate it considering, we'll simply write c first. Okay, then we'll write du divided by dx. Okay, for example, here if you take the same example, we can write dy by dx as 3 times differentiation of x square with respect to dx. Okay, so this is how we evaluate. Fine, so remember this. Next, So okay, now based on this we can look into few problems. All right, fine. Now let us, yeah, before going to the problems we have a last one. I forgot to tell you that. Yeah, so this is quite important. If y is equal to x power n, for example, you can say x square, x cube, okay, x power 5 by 2, x power 7 by 3, anything, right? Then dy by dx, so that is equal to d by dx of x power n, okay, so that will be given as n times x power n minus 1, okay. So remember this, differentiation of x power n with respect to x, it will be given as n times x power n minus 1, okay. So we'll take an example, you'll get clarity. So say if y is equal to x square, okay, so what do we write? dy by dx is equal to dx square divided by dx, okay. Here you shouldn't cancel x and x, okay, x and x here, and you should not write it as dx divided by d, okay. So this is nonsense, fine, because as I keep telling you, you should understand the basics here, right? So the dy by dx, it simply tells you the ratio of small change in y for the corresponding small change in x, that is all, okay. So when you cancel x and x here, and when you write all these things in exam, please don't write, okay, right. So dy by dx, you can write it as d by dx of x square, okay. Now compare with this, see what is n here? N is actually 2, correct? So first we'll write n, so 2, then x power n minus 1, so x power 2 minus 1. So what did we get? x2 times x power 1. So this is simply 2x, okay. Right, now let us take one more example. If y is equal to x cube, okay, so I think you can do this now. So d by dx of x cube will say, so this would be n is 3, x to the power n minus 1, so 3 minus 1, okay. So this will be 3x square, okay. Now let us take a fraction value, okay. It can be negative also, not a problem. So if y is equal to say like x power 5 by 2, okay. So I'm just picking up some random values here. So you can say d by dx of x power 5 by 2, that will be equal to, now treat this 5 by 2 as n, okay. So 5 by 2 x power 5 by 2 minus 1, okay, right. So 5 by 2, then x power 5 by 2 minus 1, so it will be 3 by 2, right. So 5 by 2 x power 3 by 2, so this is the final answer, okay, right. Now if they give something like this, y is equal to 1 by x cube, okay, then how will you solve for this? They'll ask you what is the differentiation of y with respect to x, okay. In that case, as you know, you can take that x to the denominator, the value in the denominator to the numerator, then you can say y is equal to x power minus 3, is it not? I can write like this, correct? So dy by dx, that will be equal to d by dx of x power minus 3, d by dx of x power minus 3. So you know, treat this minus 3 as n, so minus 3 x power n minus 1, so minus 3 minus 1, right. So this would be minus 3 x power minus 4, okay, minus 3 x power minus 4. You can write it as minus 3 divided by x power 4 also, both mean the same thing, right. Now this formula, you need to remember this, so we'll use it many times, okay, fine. Now let us take few example problems, okay. Let us solve few of these examples here. Now I have given I have taken y is equal to root x, right. Now the first problem, right. Now how we can find out this? So let us convert it into exponent form, right. So you can write root x as, all of us know this, we'll write it as x power half, then we'll write d by dx of x power half, right. Now which formula we'll use? X power n, differentiation of x power n with respect to x, right. Now n is half x power half minus 1, correct. So what did we get? This will be 1 by 2 times x power minus half, okay. So you can bring this x power half to the denominator, so you'll end up getting 1 by 2 to the power x power 1 by 2, okay. See that power is only for x, right. So you can write it as 1 divided by 2 root x, okay. So you can remember this relation now, from now onwards, differentiation of root x, okay. If you don't remember, you know how to do, right? So this will be 1 divided by 2 root x. Okay, so this also they'll give it as identity or as a formula. You have to remember it as a formula in some books, right? Now let us look into the next one. So here you have y is equal to x square plus 5x cube plus 9. Okay, so x square plus 5x cube plus 9. I've just written some random expressions here. Okay, so dy by dx, as I told you, treat this as u, v, w, and if you have some other functions like 9x square and everything, you can keep taking them as functions of x, not a problem, right? Fine. Now we'll write it as d by dx of x square. Okay, so differentiation of this function plus differentiation of this function, d by dx of 5x cube, okay, plus differentiation of this one, so d by dx of 9. So what is 9? Is it a variable or constant? It is a constant, right? Now d by dx of 9, so differentiation of a constant value is 0. Now differentiation of x square, so you know, from now onwards you can remember it as 2x. Okay, so 2x power 2 minus 1, so 2x will get, right? Plus, now we have seen this, right? Now you have differentiation of 5x cube. Now treat 5 as a constant, right? If you treat 5 as a constant, I told you, you have to keep that constant aside, right? First write 5, then you can evaluate this as 5 times d by dx of x cube, right? Now x cube, what is the differentiation of x cube with respect to x? We'll get it as 2x plus 5 times 3x square. Okay, so this is your final result. You can say 2x plus 15x square. Okay, so this is the result. All right, fine. Now if you look at the next problem, they are given y is equal to 4x square into 2x plus 3. Okay, so y is equal to 4x square into 2x plus 3. Here you can solve this in two ways. I'll solve by considering y as a product of two functions of x, u and v. U is 4x square, v is 2x plus 3. Okay, now you can simplify this and solve. So if you simplify, you'll get 8x cube plus what is that, 12x square, right? Then do whatever we did here. Okay, you can do whatever we did here, right? So do that and cross check. Now let us try to do it by the UV rule. Okay, so if you treat it like that, we can find out that we know that d by dx of uv, right? So d by dx of uv, d by dx of uv, you can write it as u dv divided by dx plus v du divided by dx, is it not? So u, so what is u? U is the first function. So 4x square times d by dx of 2x plus 3 plus v. V is 2x plus 3 multiplied by d by dx of 4x square. Okay, fine. Okay, now 4x square as it is, now you have to multiply it with differentiation of 2x plus 3, right? Now differentiation of 2x. Okay, now see here, you have to treat it as, this looks like a separate problem to you, I know. Okay, so this looks like a separate problem. Now if you practice a little bit, you'll pick up the speed. Okay, so differentiation of 2x, right? Now what we'll do here, d by dx of 2x means keep 2 as it is, then you'll do differentiation of x with respect to x. Okay, now here you are saying change in x with respect to change in x. Okay, so the changes dx and dx will get cancelled, right? You shouldn't say x and x will get cancelled, d and d will get cancelled. Dx by dx, it always makes sense. Okay, fine. So you will end up getting 2. Okay, you'll end up getting 2. Otherwise you can use that what was that, if you want to remember by the formula, it's fine. So x, what is the power? 1. So 1 differentiation of x power n with respect to x, you can write it as n, that is 1 x power n minus 1. So 1 minus 1. So x power 0, it is 1 only, right? So eventually you'll end up getting 1 itself. So it's just like saying dx and dx will get cancelled and you'll get 2. Now differentiation of 3 is what? 3 is a constant value, so it will be 0, right? So d by dx of 2x plus 3, it is simply 2. Okay, you will simply get it as 2 plus 2x plus 3 as it is. Okay, 2x plus 3 as it is. Now multiplied by 4x square. right? 4 outside, differentiation of x square as 2x, okay? So totally you'll get this as 8x, okay? So this is your result. 4 into 2x, straight away I'm writing it as 8x, okay? Right now you can keep the answer in a proper fashion, so you can say 8x square plus, so you can multiply and keep, right? So 16x square plus 24x, okay? So finally you'll get it as 24x square plus 24x, like that. I hope I'm right. Okay, right, fine. So okay, so this is the result. Now I want you to first simplify this expression and then try, okay? So you'll end up getting the same expression, I believe, okay? Fine. Right, so yeah, you'll get the same thing, okay? So you can cross check if you want, okay? Right, fine. Now let us take the last problem here. So you have 7x divided by 4x plus x square, okay? So let me take it here, 7x divided by 4x plus x square, okay? Now this looks like this is in u by v form, is it not? So you can write this as, so differentiation of u by v, we'll write it as v square, the denominator, then we'll write v du by dx minus u dv by dx, okay? Right, now v square, now what is v? 4x plus x square, so 4x plus x square the whole square, okay? Now that will be in the denominator. Now you have v du by dx, okay? So we keep it that way, so 4x plus x square times du by dx. Now can you say d by dx of 7x, right? So you'll get it as d by dx of 7x minus 7x times d by dx of 4x plus x square, okay? D by dx of 4x plus x square, okay? Right, so finally we have 4x plus x square times 7 minus 7x times, now differentiation of 4x, so that will be 4, right? Now differentiation of x square, so that will be 2x, okay? So the whole thing divided by 4x plus x square. Now you can simplify further, so this will be the differentiation of this ratio, okay? This is which is a function of x, okay? Fine, this is how we find